Hi everyone, I'm Justin Weiss from IBM Research, and I'll be presenting this paper called Better Together, an evaluation of AI-supported code translation. And I'd like to begin our story by picking up from work that we presented here last year, where we studied the attitudes that software engineers had in working with a generative code model. And in particular, we were interested in what we called imperfect models, which referred to the fact that they were likely to produce buggy code. At that time, we weren't sure if software engineers would feel that such models would actually be useful. But as it turned out, many software engineers felt that they would be a useful aid. And I want to pick on these two words, useful aid, because it sets up the research question that we're focused on in this work. Are imperfect generative code models useful aids? And the way we really try to capture this idea is by asking this question. Do imperfect generative code models provide a quantifiable benefit, such as helping people produce higher quality code? And as it turns out, we're not the only ones asking this question. Last year, this paper from Carnegie Mellon examined the use of a natural language to code model. And they found that even though programmers liked working with the model, it didn't actually make them more productive or improve the quality of their code. But this is the whole premise of human-centered AI. We really want to design AI systems that act as super tools that give people abilities above and beyond what they can accomplish on their own. So this is what we're examining in our work. We ran a study where we had software engineers work on a code translation task with versus without support from an imperfect generative code model. And specifically, participants had to translate two data structures from Java to Python, and they had to produce correct and complete translations. To examine the effect of AI support, we provided people a set of translations that were produced by a state-of-the-art neural machine translation model, which they could use as they saw fit. In terms of outcomes, we had three categories of measures that we focused on. And I'm only going to talk about our metrics of code quality in this talk, but I do encourage you to read our paper to learn more about these other kinds of outcomes. So here's how we assessed code quality. The first metric we used was error rate, which we computed by manually counting the different kinds of errors that occurred in a code translation, which you can see on this slide. But in addition to looking at the presence of errors, we also looked at how much functionality participants were able to correctly implement in their translations. And we did this by testing each method they implemented to figure out the proportion of methods that were translated correctly. This schematic shows an overview from a participant's perspective of what they did in the study. And what I want to show here is that each participant worked on two code translation tasks, one with AI support and one without it. Each task lasted for a fixed 30 minutes because we really wanted to understand how much more someone could accomplish when they were working with AI support. And we also wanted to avoid a ceiling effect where everyone was able to produce a perfect translation. So let's start digging into results. And if there's one thing that I would like you to remember from this talk, it's this number, 50%. So what does this 50% represent? Well, it actually represents two things. Here's our first 50%, and it comes from comparing how people did when they worked with AI support versus without it. When people worked with the AI translations, their error rates decreased from about 63% to about 31%. And this effect was both statistically significant and large, which means it was a pretty robust result. This is really great because it shows quantitatively that people produced higher quality translations when they worked with the AI model compared to when they worked alone. Now, we see a similar effect when looking at the proportion of correctly translated methods. Here we see that when people worked with AI support, their translations had a 20% increase in the PCM compared to when they worked alone, indicating that the imperfect AI translations really were useful. So these results are really encouraging, but you may be wondering how much credit should go to the participant versus the AI system. Maybe it was just the case that the AI translations were so good that people didn't need to do anything to them in order to do well on the translation task. So to understand this, we took a look at each participant and tried to assess whether or not they made a quality improvement to their set of AI translations. In this chart, the x-axis shows each individual participant, and the y-axis shows the error rate of their code. Now, these blue lines represent the quality of the AI translations that people started with, and there's two things going on here that you may notice. First, some of these lines are kind of short, and some of these lines are longer. And that's because one factor we examined was the number of translations we provided to people, either 1 or 5. And we looked at this because of how the machine learning community evaluates the quality of code translation models, where the model is allowed to produce many translations to see if any of them passes a set of unit tests. Now, the next thing you may have noticed is that some of these bars are higher than others, which represents the fact that some people were given a set of worse quality translations, and others were given a set of better quality translations. And we did this to try and understand how good a translation needed to be in order for it to be useful. We have a lot more detail in our paper on how the quantity and quality of AI translations affected people's work, but for now, I'll just say that the quality of the AI translations didn't affect people's ability to make improvements to them. So now let me add some data points. Each of these points represents the quality of the translation produced by the participant at the end of the 30 minutes. These dots are colored based on how their quality compares to the quality of the AI translations they worked with. The blue circles represent cases where a participant improved quality by reducing the error rate of the AI translations. The orange squares indicate that the participant's translation was inside the AI's quality range, and the red triangles indicate that the participant's translation was actually worse than the AI. And here's our second 50%. It was actually 53% of participants were able to make quality improvements to the AI-produced translations, which suggests that some people were really successful in working with them effectively, but not everyone. Now, you may be wondering, why were only some people able to make a quality improvement? This is an interesting question, but I'd actually argue there's a more important question to ask, which is, how can we help more people be effective when working with the AI? We believe that one answer has to do with how people interact with the AI model. In our study, there really wasn't any interaction with the model beyond just taking its output and working with it. It was really like the hello world of interactive experiences. But many of our participants indicated a desire to ask questions of the model to understand what it was doing, why it produced the output it produced, and what other options it considered. This raises some very interesting research questions about the explainability needs that people have when working with generative code models. And for more on this, I'd like to recommend checking out our other IUI paper this year, which examined explainability needs for generative code models. Okay, time to wrap up. I'd like to conclude by giving you 4 reasons to go read our paper. First, we found that the imperfect AI translations really were useful aids. When working with the AI translations, our participants produced better quality code and they were able to complete more of the translation task. Second, we discuss in the paper how the presence of AI support transformed people's work process from being an act of production where they had to write code to being more of an act of review and fix-up. Third, we learned that working with multiple translations was a horrible user experience. Neural machine translation models are usually allowed to produce something like 25 translations to see if any of them correctly passes unit tests, in order to achieve a high level of accuracy. But for the people in our study, even just 5 translations was very frustrating because it was difficult to understand the differences between them. This strongly motivates the need for some intelligence in the user interface that helps people capture the benefits of having multiple translations without being overwhelmed. We have some ideas about this in the paper, and in our IUI demo, we show them off in a real code editing environment. So that's my talk, and thank you.